Right, welcome to solving absolute value equations. To solve absolute value equations, the first thing you need to know is what absolute value actually is. So an absolute value means the distance from 0 on the number line. Okay, so that's what it means. So, for example, this first one, the absolute value of x is equal to 4. That means this is the distance from 0 is 4. So where are the spots where the distance from 0 is 4? I ask you, it's 4 and negative 4. So because the distance from here to here is 4, distance from here to here is 4. That's it. That's what it means. But what happens when we do something like this? The absolute value of x plus 1 is equal to 7. That means this distance right here is 7, or this distance right here is negative 7. Okay, so like, or this value on the inside is negative 7. So what I like to do is I like to say that this, whoops, I don't know what that one just was. Whatever, okay, that's really big. Okay, I take this absolute value and go over to this side, and I say it could be, that's whatever's on the inside could be 7, and then this absolute value points to another, could be negative 7. So this number could be 7, or that number could be negative 7, because if, you know, it's distance from 0 on the number line. So we simply solve this guy. So x could be 6, or x could be negative 8. So then it could be here or here. For equations, we don't generally use a number line, but just so that you can see, you know, x plus 1 is equal to 7. So if 6 is x, x plus 1 was 7. And if x was negative 8 here, x plus 1 was also at 7. So that's what it means. Whatever's on the inside could be at 7, and it could be at negative 7. So that's the basic idea. We simply set up two equations, and I just use those little absolute value symbols to remind myself that I have to create two equations and then solve. So I don't really need that number line for equations because it's just two answers. Okay, but that's the concept. So you have to be careful though when you're solving absolute value equations, because it's the absolute value. It's at the absolute value that it, you know, what's on the inside that is the distance from 0. So we have something extra out here. That extra thing can't be there before I set up the two equations, or, you know, when I'm setting up the two equations. So since this is 3 times 2x minus 4, I can divide both sides by 3 and get the absolute value of 2x minus 4 is equal to negative 2. Now you could go ahead and solve this one and do all that good stuff. But the problem is the distance from 0, 2x minus 4, this distance from 0 has to be negative 2. And it's saying distance is equal to negative 2. That can't happen. So this particular problem, you could solve it all. Then you should check. But this distance, there can be no solution here. Okay? So it is important. You could have solved this whole one, set up the two equations, get the two answers, but then when you go back and check, it's not going to work. So we're going to focus on the check more on the next one. So let's look at the next one. All right, so this one has a lot of wonderful things happening here. So it's kind of like the pinnacle of the kind of problem we will be seeing. So you have to look at it. You have to make sure that absolute value is by itself before we set up our two equations. So if you look at this side of the equal sign, we have the absolute value, which needs to be by itself. So there's two parts of it that need to go away. That 2x needs to go away, and so does that negative. So it's 2x minus x plus 3. So it's connected with, addition or subtraction. So we change the sign of the 2x and bring it over to this side. So this is negative 2x plus 9. Remember, you can't add a negative 2x and a 9. They are unlike terms. Then this negative, if you want to think of it like it's a negative 1 times this, we simply divide by negative 1, both sides. So it's the absolute value of x plus 3 is equal to, and now when I divide that negative 1 into both the 2x and the 9. And when I divide it into the negative 2x, I get a positive 2x. And when I divide it into the 9, I get a negative 9. And now I can set up my two equations. So I like to create my two equations here. And what's inside the absolute value stays the same. Okay? So do not change that. Everything outside the absolute value is going to change. So the positive 2x went to negative, and the negative 9 went to positive. I wrote the second equation first, but you get the idea. The other equation is exactly the same. So one equation is exactly the same, and the other equation, everything outside the absolute value changes. And then we simply solve these two equations for answers. So for this one, x is 2. And then for this one, x is 12. Now we're going to focus, like I said before, we should focus on that check to make sure that this works. Both of these answers are appropriate. Because anytime you have two answers, it is a good idea to check them, even one. All right, so x equals 2, x equals x equals 12, as long as I didn't mess up. So we come back up here and we should do a basic check for 2 and 12. Okay. Alrighty, so we plug them in. We plug 2 in, this original equation, so it's 2 times 2 minus the absolute value of 2 plus 3 equals 9. Okay, so that's 4 minus the absolute value of 5 equals 9. So the absolute value of 5, evaluating it, it's the same. If 5 was negative, it would be positive. But 5 is positive here. So it's 4 minus 5 equals 9, and it's negative 1 equals 9. That does not work, so that one is not a solution. The other one, we want to try x equals 12. So it's 2 times 12 minus 12 plus 3 equals 9. So this is 24 minus 15 equals 9, or the absolute value of 15, which is just 15 in this case. So 24 minus 15 is 9. 9 equals 9. Checks. So the only solution there is 12. Okay, if I have time, I'll remake this video because I had to make it fast. But hopefully you get the idea. Isolate the absolute value. Create two equations. One is the same without the absolute value. The other, you change everything on the outside of the absolute value and solve them both and go back in and check. Have a great day.